All right, one last thing before I get off here. I did want to talk to you guys about the AA theorem similarity and give you a few examples of what that might look like. So for these pairs of triangles here on this little notes guide, we're just going to say similar or no, kind of go through them one by one. All right, here we go. First one, we have a triangle inside of another triangle, and we have segment KN is parallel to segment LM. Now remember guys, whenever you have lines that are parallel, that means you need to look out for corresponding angles, alternate interior, alternate exterior, all that jazz. So right off the bat, I know that angle K and angle L are corresponding angles, thus they must be congruent. Same thing with N and M. They have to be congruent as well. And then of course, obviously these triangles share angle J. So these triangles definitely are similar by AA. We know they have 3 sets of angles in common, but we only need 2 to have the theorem. Alrighty, next example. We have a smaller triangle kind of nestled inside of a larger triangle, PRS. This one gets a little hairy. So I'm going to redraw PQT for you outside. We have 50 and this is 45. I'm so sorry that's so tiny, guys. 50, 45. And then here we have angle P is 50. So they have at least one angle in common, the shared angle. And then angle R is labeled 85 degrees. I don't see an 85-degree angle here quite yet, but I could do a little math and figure out what angle T is. Let's see if it matches up. Okay, so 50 plus 45, that's going to give me 95 degrees. I know the angles in a triangle have to add up to 180. So let's see what we're missing. Oh, hey, we're missing an 85-degree angle here. Angle T is 85. So that means angle T is congruent to angle R, and thus triangle, now I'm going to be really careful writing this one, PRS is similar to triangle PTQ by AA. Alrighty, next one, we've just got some parallel line markers here and here. Again, you guys should be very trained. As soon as you see those, go ahead and mark alternate interior angles congruent. So we know that G is congruent to N. We also know H is congruent to M. Of course, we're used to seeing any vertical angles and marking them congruent instantly. We always know that they are congruent. So therefore, triangle, let me call this GHK, is similar to triangle NMK by AA similarity theorem. All right, got a few more to get through and then we are done. Triangles over here. Alrighty, so here we have F and G and H are all congruent to each other. Likewise with S, R, and Q. So not necessarily labels that indicate, an angle on here congruent to an angle on here, but these 3 angles are congruent to each other and these 3 angles are congruent to each other. So that would tell us, if the angles in a triangle add up to 180 and all 3 are equal, we could do a quick little math. 180 divided by 3 equal angles, it's going to be 60. So all these angles must be 60 degrees. Same thing over here. So therefore, we have some similar triangles over here by AA. Not only are they similar, they are equilateral, equiangular, regular triangles. Holy smokes. So yeah, all equilateral triangles, meaning ones that are the same side on all 3 sides, will be similar. It's a rule. You can remember that. Okay, next one, we have some right triangles. that we're comparing here. So I know I have a 90-degree angle here. That means we must have a 90-degree angle there. Again, deduction, we're using triangle sum theorem here. 90 plus 32 is 122. That means this missing angle here has to be 58 degrees in order to get me to 180. So now I have a 90-degree angle in common. I have a 58-degree angle in common. So therefore, triangle, let me see, FED is similar to triangle FDC. Again, by AA. And then we're going to end with the easiest one of them all. Got a smaller triangle nestled inside of a larger triangle. Obviously, that's marked congruent already for you. 52 is equal to 52. And obviously, they have a shared angle, A. So, of course, the third angle is going to be congruent. And triangle ABE is similar to triangle ACD by AA. You guys are awesome. Keep up the good work. Keep logging into Khan Academy. I know it's not as good as me. Just tooting my own horn here. Just kidding. But please stay with it. I miss you all. Hopefully we'll be back in the classroom soon. See ya.